Hemophilia is a classic example of a recessive X-linked trait. In a healthy individual, the body combats the hemorrhaging process first by constricting vessels at the site of injury. Then a complex series of events called the coagulation cascade activates structures known as platelets. Usually the platelets interlock to form a plug called a clot, which slows or stops the bleeding. In individuals with hemophilia, however, the coagulation process is disrupted. The platelets either do not mesh tightly enough, or sometimes they will not interlock at all. Untreated, this condition could cause potentially fatal bleeding, even from a very small wound. Individuals with hemophilia are almost exclusively male. So how is it possible that the genes for this condition are carried on the X chromosome rather than the Y? Hemophilia is recessive. Because females have two X chromosomes, receiving one with the mutation would not cause them to develop hemophilia. Their second X chromosome, carrying the dominant healthy gene, would overpower the recessive hemophilia gene. To develop hemophilia, they would need to receive the mutation from both parents, which is highly unlikely, about a 1 in 25 million chance. Men only have one X chromosome, and their Y chromosome can't overshadow the hemophilia gene. If their X chromosome contains the mutation, they will have hemophilia. Despite not actually suffering from the debilitating effects of hemophilia, women with one copy of the gene are carriers for the condition. They are capable of passing it on to their descendants. If they pass the hemophilia gene on to a daughter, the daughter would also become a carrier. If they pass the gene on to a son, he would develop hemophilia. If a carrier woman and a healthy man reproduced, they have a 50% chance of having a daughter who is a carrier for hemophilia, and a 50% chance of having a son who has the actual condition. One of the most famous examples of this happening is in the royal houses of Europe about a century ago. Queen Victoria of England was a carrier for hemophilia. She passed the mutation on to several of her children, and thus on to the royal houses of Germany, Spain, and ultimately Russia. Her granddaughter Alexandra married Tsar Nicholas II of Russia, and their son's hemophilia played a direct role in the downfall of the last Tsarist regime.